The National Electrical Code, specifically the 2005 edition in this instance, does not contain any provisions that mandate a specific orientation for the grounding connector on electrical receptacles. This means that nationally, there is no requirement within the NEC that dictates whether the grounding pin, the round hole, on a receptacle must be positioned above, below, or to the side of the other two slots, which are the neutral and hot connections. It is crucial to understand that the NEC establishes a baseline for safe electrical installations, but it is not the only authority governing these practices. Local jurisdictions, such as cities, counties, or even states, have the power to adopt, amend, or even create their own electrical codes that may be stricter or more specific than the NEC. These local codes take precedence over the NEC within their respective jurisdictions. Consequently, it is entirely possible that the reason you are encountering conflicting information about receptacle orientation is because of these local variations. Some jurisdictions might have indeed implemented amendments to the NEC or have their own distinct regulations that mandate the grounding connector to be positioned at the top. This local rule would then be the governing standard for electrical installations within that area. To definitively resolve the conflicting information and ascertain the correct procedure for your specific location, the most reliable course of action is to consult your local electrical inspector. Electrical inspectors are the authoritative figures responsible for enforcing the electrical codes within their jurisdiction. They possess in-depth knowledge of the specific regulations and amendments that are in effect in your area. Reaching out to your local electrical inspector will provide you with a clear and accurate understanding of whether there is a local requirement for grounding connector orientation, and if so, what that specific requirement entails. Without consulting the local electrical inspector, one might make assumptions. This could lead to installations that do not comply with the local codes. Compliance with the local electrical codes is not merely a matter of following rules, it is essential for ensuring the safety of electrical installations and preventing potential hazards. Incorrect wiring or improper grounding can create dangerous situations such as electrical shocks, fires, and equipment damage. Therefore, it is always recommended to prioritize safety and adhere to the specific regulations in place within your jurisdiction. Electrical codes and standards exist to protect people and property from electrical hazards. These regulations cover a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is important for all electrical professionals to stay up to date on the latest codes and standards. The NEC is updated every 3 years, and local jurisdictions may also make changes to their electrical codes on a regular basis. It is also important to note that the NEC is not a design manual. It provides minimum requirements for safe electrical installations, but it does not provide detailed design guidance. Electrical engineers and designers should consult other resources, such as manufacturers' instructions and industry standards, to ensure that their electrical designs are safe and effective. Continuing education courses, trade publications, and professional organizations are valuable resources for staying informed about changes to the NEC and other electrical codes and standards. In addition to consulting your local electrical inspector, you can also refer to the following resources for more information about electrical codes and standards: the National Electrical Code, your state or local electrical code, and the websites of professional electrical organizations. Firstly, understand the scope of the NEC. It's a comprehensive document, but it's not exhaustive and is often amended locally. Secondly, realize the role of local jurisdictions. They have the final say on electrical installations within their boundaries. Thirdly, prioritize consulting your local electrical inspector. They are your primary source of information on local requirements. Furthermore, safety should always be your top priority. Adhering to electrical codes ensures safe installations. Moreover, remember to stay updated on code changes. The NEC is updated every 3 years, and local codes may change more frequently. In addition, electrical codes are not design manuals. Consult other resources for detailed design guidance. Finally, take advantage of available resources such as continuing education courses, trade publications, and professional organizations. Grounding is a critical aspect of electrical safety. It provides a low impedance path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and prevent electrical shock. The grounding system consists of the grounding electrode conductor, the equipment grounding conductor, and the grounded conductor. The grounding electrode conductor connects the grounding electrode to the service equipment. The equipment grounding conductor connects the non-current carrying metal parts of electrical equipment to the grounding system. The grounded conductor, also known as the neutral conductor, is intentionally grounded at the service equipment. Proper grounding is essential for protecting people and property from electrical hazards. There are many different types of grounding systems, each with its own advantages and disadvantages. The most common type of grounding system is the grounded system, in which the neutral conductor is grounded at the service equipment. This type of system provides a low impedance path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and prevent electrical shock. Another type of grounding system is the ungrounded system, in which the neutral conductor is not grounded. This type of system is less common than the grounded system, but it is sometimes used in industrial applications where it is important to minimize the risk of ground faults. In an ungrounded system, a ground fault will not trip the circuit breaker or fuse, but it will cause a voltage to appear on the ungrounded conductor. This voltage can be used to detect the ground fault and take corrective action. The type of grounding system that is used in a particular application will depend on the specific requirements of the application. Factors to consider include the risk of ground faults, the need for personnel protection, and the cost of the grounding system. Receptacles are an important part of the electrical system. They provide a convenient way to connect electrical equipment to the power supply. Receptacles are available in a variety of different types, each with its own specific purpose. The most common type of receptacle is the duplex receptacle, which has two outlets. Duplex receptacles are typically used in residential and commercial applications. Another type of receptacle is the single receptacle, which has only one outlet. Single receptacles are typically used for appliances that require a dedicated circuit. Receptacles are also available in different voltage and amperage ratings. The voltage rating of a receptacle must match the voltage of the power supply. The amperage rating of a receptacle must be greater than or equal to the amperage of the appliance that will be plugged into it. It is important to select the correct type of receptacle for the application. Using the wrong type of receptacle can create a safety hazard. Electrical safety is paramount. Always to energize circuits before working on them. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work on electrical equipment when you are wet or standing in water. If you are not comfortable working on electrical equipment, hire a qualified electrician. Electrical work can be dangerous, and it is important to take precautions to protect yourself and others. Proper wiring is essential for safe electrical installations. Incorrect wiring can create a variety of hazards, including electrical shock, fires, and equipment damage. All wiring must be installed in accordance with the National Electrical Code and local electrical codes. Wiring must be properly sized for the load that it will carry. Wiring must be properly insulated to prevent electrical shock. Wiring connections must be made properly to ensure a reliable connection. Overcurrent protection is another important aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Overloads occur when the current in a circuit exceeds the rated capacity of the wiring. Short circuits occur when there is a direct connection between two conductors of different polarity. Overcurrent protection devices trip when the current in a circuit exceeds the rated capacity of the device. This helps to protect the wiring from overheating and causing a fire. Electrical inspections are an important part of the electrical safety process. Electrical inspections are conducted by qualified electrical inspectors to ensure that electrical installations are in compliance with the National Electrical Code and local electrical codes. Electrical inspectors check for a variety of potential hazards, including improper wiring, overloaded circuits, and defective equipment. If an electrical inspector finds any violations, they will issue a notice of violation. The notice of violation must be corrected before the electrical installation can be approved. Electrical inspections help to ensure that electrical installations are safe and in compliance with the applicable codes. Understanding the NEC and local electrical codes is a continuous process. Electrical codes and standards are constantly evolving to reflect changes in technology and to address new safety concerns. It is important for all electrical professionals to stay up to date on the latest codes and standards. This can be accomplished by attending continuing education courses, reading trade publications, and participating in professional organizations. By staying informed about the latest codes and standards, electrical professionals can ensure that they are providing safe and compliant electrical installations. Furthermore, consider the context of the NEC. The NEC is a consensus-based document that is developed by a committee of experts from various fields, including electrical contractors, engineers, manufacturers, and inspectors. The NEC is updated every 3 years to reflect changes in technology and to address new safety concerns. The NEC is not a law, but it is widely adopted by state and local governments as the basis for their electrical codes. The NEC is an important resource for electrical professionals, but it is not a substitute for sound engineering judgment. Electrical professionals should always use their knowledge and experience to make sure that electrical installations are safe and compliant with the applicable codes. Understanding the language of the NEC is crucial. The NEC uses specific terminology to describe electrical equipment and wiring methods. It is important to understand this terminology in order to properly interpret the NEC. The NEC also contains many tables and figures that provide information about electrical calculations and wiring practices. It is important to be able to use these tables and figures correctly in order to ensure that electrical installations are safe and compliant. Electrical safety is a shared responsibility. Electrical professionals, homeowners, and business owners all have a role to play in ensuring that electrical installations are safe. Electrical professionals must follow the NEC and local electrical codes when installing and maintaining electrical systems. Homeowners and business owners must maintain their electrical systems properly and avoid overloading circuits. By working together, we can all help to prevent electrical hazards and keep our communities safe. In addition to the topics discussed above, there are many other important aspects of electrical safety. These include arc flash protection, grounding and bonding, surge protection, and lightning protection. Arc flash is a dangerous phenomenon that can occur when there is a short circuit in an electrical system. Arc flash can cause serious burns, blindness, and even death. Grounding and bonding are essential for preventing electrical shock. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and prevent electrical shock. Bonding connects all of the metal parts of an electrical system together to create a common ground. Surge protection is used to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other events. Lightning protection is used to protect buildings and equipment from lightning strikes. Lightning protection systems consist of lightning rods, conductors, and grounding electrodes. By understanding and implementing these electrical safety practices, we can all help to prevent electrical hazards and keep our communities safe.